Hi, thanks to viewing this video. Today I will talk about how to set the SparkML+GPU environment in the AWS platform until the final part of my tutorial. So at the first, I have prepared the instance. I have prepared the image for the instance in AWS for the GPU SparkML+GPU. And you can launch the instance from here. So there are three choices here. First is My AMIs, the second one is AWS Marketplace, and the third one is Community AMIs. You could select My AMIs to go to the next step, and then you can find My AMI called 15688 Spark GPU tutorial, and the AMI number is here. Then you select this AMI to get into the next step. And then we would like to choose the instance type for this AWS VM instance. And since this instance is designed for the GPU, so we should to select specific instance. And we should select this one called G2.2xlarge. Actually, our system only supports this instance called G2.2xlarge. Then we continue to next step. And then we will only deploy one instance in the account, since the instance limit in your AWS account for G2.2xlarge is 1 defaultly. So we would like to deploy the master and worker in the same node. And then we go to next step. It's add storage. We will choose 60 GB here. And then next add tags. At where we will choose a tag called project 15688, and then go to next step, configuration security group. So since we would add a security group rule here, it is called OTCP rule, and open to any instance in the internet space, and then go to next step, and then finished it. It will ask you to provide the key pair, and I have the key pair called personal, so I will use the personal key pair to continue into next step. Click the launch instance, and then view the instances. Then you will find a circle here. It is a new instance we have just initialized. The tag tells me that the project 15688, we just set it before, the instance type G2.2xlarge, and put in the availability zone US East 1. Since this image is only provided and only available in the North Virginia, so you should only have the availability zone in the US East 1, and the instance state and status check initializing. So we choose this one and find the public DNS of this instance and copy this public DNS. Then we could open any terminal we would like to use for this program. We open this terminal and then copy my IP address of the SparkML+GPU instance here, and then go to this one. So the work directory is called SparkML+GPU-physics. It is put in the root directory of this VM instance. The first thing we should do, get into this work directory, and then we could see there it is a Maven repo here. The first thing, we use the Maven install to compile the source code. It will take about 1 minute to 2 minutes to complete the total compile process. In this program, we will compare the performance of SparkML+CPU and the performance SparkML+GPU. As we all know that the GPU performs well at the parallel calculation, especially for a large dataset or large matrix. But it really depends for the dataset size. If we have a large dataset, it may be really well for the GPU workload. But if we only have a small dataset, maybe we need to take more time to transport the data from the main memory to GPU memory, since the main memory and the GPU memory is isolated. Therefore, in this program, we will go from the very beginning, go from a very small dataset with only 10 data points, and then in the final we will go to a large dataset about 600,000 data points for logistic regression. And to keep it stable, we will only run 5 CPU iterations, and so that we can compare the performance between the CPU and between the GPU. Okay, so we can see the sign here called build success. It means that our program has been ready for the next step. And then we review the directory organization. There is a Python file here called run_gpu.py, and then we will execute the command python run_gpu.py to go continue. And we would wait for that. And use some time to do the initialize things. Since we have to set up the Spark environment in this Python file. Okay, it has begun. We can see at the first, the training set data points is 100 points, and the dimension is 10 dimensions. The GPU used 236 milliseconds, and the CPU only used 126. So, for a small data set, usually the CPU will perform well than the GPU. We will compare that. Within the increasing of the training set data size, from that 100 to 1000 to 10,000 to 100,000, we can see that the GPU time has not increased obviously. Sometimes it even decreased, but the CPU time used here decreased linearly. And now, the GPU time has been much less than the CPU time here. We will go through this dataset. So now it is 400,000. The GPU only used less than half seconds, but the CPU has used about 1.5 seconds here. So we will not continue for this program, and I think you have experienced the power of the SparkML on GPU, which is much better than the SparkML based on CPU for a large dataset, especially for the situation we have covered in the tutorial. So have fun in that. You can test more program here and enjoy the power of the GPU. You will like that.